Learners are given two half cells, half cell 1 and half cell 2. During an investigation to identify the two half cells, the learners connect each half cell alternately to a cadmium half cell under standard conditions. We have the results for the first combination and the second combination. The first question, 4.01, write down 3 conditions needed for these cells to function as standard cells. Well, the pressure at 101.3 kilopascals. Another condition is the temperature at 25 degrees Celsius. And lastly, we need the concentration at 1 mole per decimeter cube. This is our 3 standard conditions. Let's go to 4.2, 4.2.1. For the first combination, let's identify the anode of the cell. So in our first combination, we are given the net cell reaction. Well, we have cadmium losing 2 electrons to form cadmium. So that is our anode. Our anode is cadmium. So we're going to have that there. At the anode, oxidation occurs. There's a loss of electrons. And as we can see, cadmium loses electrons in our first combination. And 4.2.2, we're supposed to identify Q using a suitable calculation. Well, what information do we have? We have the EMF of our cell. It is equals to 0.13 volts. We have the standard reduction potential of cadmium. It is equals to minus 0.4. So in order for us to determine Q, we're going to say that the EMF of our cell will be equals to the reduction potential at the cathode minus the reduction potential at the anode. So we're going to have 0.13 being equals to the reduction potential at the cathode. At the cathode is where we have Q, as we have already deduced that the anode is cadmium. And the reduction potential of cadmium, that is minus 0.4. So we're going to have 0.13 being equals to the reduction potential of Q plus 0.4. It should be easy to see that the reduction potential of Q will be equals to 0.13 minus 0.4, which is just equals to minus 0.27 volts. So Q is nickel if you go to your table of standard reduction potentials. Right, that is 4.2.2. That is how we solve those kind of questions. Let's go ahead and take a look at 4.3. So in 4.3, we're interested in our second combination. And 4.3.1, the oxidation of reaction. Well, what happened in reaction 1 is still happening in reaction 2. Cadmium is losing electrons. So that is our oxidation of reaction. We're going to have cadmium giving us cadmium 2 plus 2 electrons as our oxidation of reaction. That is 4.3.1. Let's go ahead and do 4.3.2. Name or formula of the metal used in the cathode compartment. Cadmium is our anode, so our cathode is R2, which happens to be a gas. If we have a gas, our electrode is going to be platinum. That is 4.3.2. The last question, 4.4. Identify the following species in order of increasing oxidizing ability. So the oxidizing agent undergoes reduction. We need to know that. So let's take a look at this. Between Q to the 2 plus and CD to the 2 plus, Q to the 2 plus is a strong oxidizing agent as it goes under reduction. So we know that Q to the 2 plus is a stronger oxidizing agent compared to CD2 plus. If you look at our second combination, we can come to the conclusion that R2 is a stronger oxidizing agent compared to CD2 plus because it also undergoes a reduction. The only thing that we now have to figure out is which one is a stronger oxidizing agent between Q to the 2 plus and R2. With cadmium, Q to the 2 plus and R2 act as our cathode. So whatever oxidizing agent between these two will lead to a higher EMF will be our strongest oxidizing agent. And if you look at the cell potential, R2 is giving us the highest cell potential. So we can say that CD2 plus is the weakest, followed by Q to the 2 plus. And the strongest oxidizing agent is R2.